I think we can start. Thank you all for coming. So this is the final defense of Mariela Rodriguez. I just want to say a few words of introduction. Mariela is from Peru, and she graduated from the Pontifical University, Catholic University there, and she moved to Florida in 2004 to join her research. And Mariela has always been interested in forensic science and forensic applications of chemistry. And in fact, she earned a Master of Science here in 2007 in pharmacy and pharmaceutical sciences, and then she did forensic drug chemistry. So in addition to that, together with Jim Weinefolder, we had a collaboration with the Miami International University, with the forensic group there led by Professor Almiral, and they were interested in characterizing glasses, and this is the topic that she started working on. And she not only worked on the chemical characterization, qualitative identification of several glasses, but also she tried to develop quantitative methodologies for determining the trace content in those glasses. And this is the result of her research, which she is going to present today. Now, the rules are the usual. She will give a 20 minutes approximately compendium of all the research. Obviously, she will have much more to say than what she will show. She will be able to show in 20 minutes. And then the students can ask questions, and then they leave, and we will ask questions. Please.
Thank you, Nico, for the introduction. Good morning to everybody, and thank you for being here today. I will present briefly a summary of some of the most particular results that we get in this research project. As Nico mentioned, we have applied in this research the technique of laser-induced vector spectroscopy for a discrimination of glasses using correlation analysis. Here I mean that we use linear and rank correlation methods to be able to characterize glasses and tell if these glasses are coming from the same source or not. We also, in this study, we look at different instrumental parameters, and we were able to compare 4 commercial instruments for leaves and do correlation analysis using these 4 instruments. We also look into the quantitative analysis of glass. It will be very important if we can characterize unknown glasses by their trace elements present. So in quantitative analysis, we will look at 2 things. First, the normal or conventional calibration plot of signal versus concentration, and then a normalized approach that takes use of the peak intensity versus the background. Here is a brief outline of this presentation. I will start talking about the characteristic of the leaf process and the importance of glass as a forensic evidence. Then I will go into a little more detail on the 3 research projects I have been working at, and at the end, I will finish with the conclusions and recommendations for future work. From this research, we have already published 1 paper, and we have 2 other papers in preparation. So first, I will briefly talk about the technique of laser-induced vector spectroscopy, in which a high-power short-pulse laser is focused onto a sample surface. A very energetic plasma is created, which is rich in electrons, atoms, and ions. Then we can collect the radiation and get important information about the elements present in the sample. This is a graph of the typical instrumentation for leaves, in where we have a laser that is focused into the sample surface by a lens, and then the plasma radiation can be collected by another lens or by a fiber optic and directed towards the spectrometer and then being detected. This is a typical spectra for leaves, in where we get intensity of light versus wavelength, nanometers. In this research, or in my results, I will be talking about the net intensity, especially when I do calibration plots. And by net intensity, I mean the peak intensity corrected by the surrounding background. In some other calibration plots, I will just talk about the intensity, and by that means just the highest value in intensity without any correction for the background. So LEAFS, in comparison to other analytical techniques, has very clear advantages, such as simultaneous multi-element detection capability. There is no need for sample preparation, and virtually any kind of sample can be analyzed: solids, liquids, aerosols, or gas. Also, LEAFS is considered a minimally invasive technique that only requires very small amount of samples, and is even considered as a non-destructive technique. The analysis is fast and in real time. Even though we have these impressive advantages for the LEAFS technique, there is still some limitations, such as a low precision in the range of 5 up to 15%, high detection limits, mostly in the range of ppm, and the presence of spectral interferences and matrix effects. In this research, we are looking at the LEAFS, we are applying LEAFS for the determination of metabolic samples, but in special, we are focusing in glass. Glass is an important sample for forensic purposes because pieces of glass found in a crime scene can involucrate a suspect with the perpetration of a particular crime. Forensic scientists look at pieces of glass and try to determine if these two samples may have shared a common origin. Therefore, the methods for discrimination of analysis of glass for forensic purposes should be able to work with very small samples and also should provide a very high confidence in the results. Glass is an amorphous product of fusion cooled to a rigid condition without crystallization. Glass as a chemical matrix is mainly composed of silica sand, silicon dioxide in concentrations of about 70%. Soda or sodium carbonate is added to reduce the fusion, the melting point in the preparation of glass. Lime and dolomite are added as stabilizers in the process of glass. Then, most of these glasses, and here we have a typical composition of a soda lime glass, most of these glasses have very similar concentration of the main elements, such as silicon, magnesium, calcium, sodium. So if we want to have discrimination analysis, it would be very important if we can focus into what makes these glasses different, which is the presence of minor and trace elements. So, trace elements are present in glass because mostly as contaminants in the raw material or modifiers added intentionally depending the glass they are preparing, and also as contaminants in the manufacturing process. To identify glass fragments, first, forensic scientists will look into physical properties, such as color, thickness, density, and refractive index. Refractive index has been a technique of choice in the last 40 years, but lately there is less variability in the values of refractive index for many samples, and therefore now the analysis is shifting mostly to the elemental analysis of the glasses. Techniques that have been used or are used for discrimination analysis of glass are X-ray fluorescence, ICP mass spec, and laser ablation ICP mass spec. Each technique has its own advantages, but their cost is a little bit high, and therefore not many forensic laboratories are using these techniques, especially laser ablation ICP mass spec, because of the high cost of the instruments involved. In this research, we are proposing to use LEAFS as an alternative method to characterize glasses. The first project that we look into is a correlation analysis and the discrimination of glass. Different sampling parameters have been studied in this research. Here is one of the most significant results or more significant behavior that we see for our glasses. These three graphs show the variation of the intensity, of the net intensity